All right, so let's go ahead with this last section of this unit. This is graphs of tangent functions. So these end up looking quite a bit different from sinusoidal. And that might not be really surprising when we think about what happens in our unit circle. In our unit circle, when we have standard rotation, our y values as we rotated around went up to a maximum of y, down to 0, down to a negative of minimum of -1, and then back to 0. So as we kept going around the circle, our sine values went up, and then they came back down, and they were positive up here, and they were negative down here. So when our angle of sine increases, and even as it goes beyond 2 pi or beyond 360 degrees, that's what's going on. If we look at cosine, cosine is left and right. So it starts at a value of 1 when our angle is 0. And as we rotate around, it gets negative, and then it starts to increase, and it becomes positive. But it always just cycles between these maximum to the right of negative or of +1, and then to the left of -1. And so it just always goes between -1 and +1. Cosine does. So sine and cosine are kind of the same. But when we look at what's happening with tangent, as we go around the circle with tangent, remember tangent is y over x. And tangent at 90 degrees or at pi over 2 becomes 1 over 0, which is undefined, which is infinite. When we get to 180 degrees or pi, then y over x becomes 0 over 1. So tangent is just 0 there. But then when we get down to 270 degrees or 3 pi over 2, then our y over x is -1 divided by 0, which is negative infinity. And so it's undefined there. And so we have these, we have that tangent goes between these very, very big values, because it approaches these undefined angles when angle is undefined. So it ends up being kind of, it's going to look way different. So when we going through these notes, when an angle is drawn in standard position, and the ratio of tangent is y over x, we can also write it in terms of sine and cos, because sine is your y. So tangent is sine theta over x. So sine theta over cos theta. So if we try to start to piece this together, when our angle is negative pi over 4, if we are looking at tangent, negative pi over 4 is here. Then our tangent is y over x, so it's negative root 2 over positive root 2. It's -1 there, because the coordinates here are root 2 over 2, comma, negative root 2 over 2. So at all of the 45s, remember that the x and the y coordinates are the same quantity. The only thing that's going to be different is which is positive and which is negative. So at negative pi quarters, your y is -1. At 0 degrees, tangent is y over x, and the y is 0 there, so it's 0 over 1. So tangent of 0 is 0. At pi quarters, at positive pi quarters, our y and our x will both be root 2 over 2. And so at pi quarters, this is 1. At pi over 2, this is what I was talking about a couple minutes ago, y over x is 1 over 0. It's undefined is what we write for that. And if we're dividing by 0, you can guess and you can imagine that we're going to have an asymptote there, and that's exactly what's going to happen. It's undefined. At pi, pi is over here, so pi is over here. Y over x is 0 over 1, 0 over -1 technically. 3 pi over 2, again, is undefined. And at 2 pi, as we go all the way around here, y divided by x is 0 divided by 1, so this is just 0. When we start to graph this, we don't really have that much information. Pi quarters comma -1 is here. 0, 0, pi quarters comma 1. And then 1/2 says it's undefined. I'm going to draw that as a vertical asymptote. And then at pi, we have 0. At 3 pi halves, we have undefined. And at 2 pi, we have 0. Well, if we did these in-between values, what we would get at 3 pi quarters, and what we would get at 5 pi quarters would be these. What we would get if we went to the left, negative pi halves, it would just be this again. So it's going to go through those 3 points, but it's not going to be linear because we have these asymptotes. What it ends up doing is so it'll hug this asymptote, so as we increase through here, and it's going to be this nice smooth curve that looks kind of like that. Right around 0, it ends up being an inflection point. So it kind of does a little bit more of a wow like that, I suppose. Kind of like a cubic function does. This one has an inflection point there. And so it ends up being a curve that looks like that. One strategy to draw this inflection point is if I start right from pi, if I go to the left, out at a horizontal and then start to decrease, and if I do the same thing coming out this way, it ends up being this nice inflection point that we draw there. So it ends up being this kind of process. Is it a periodic function? Just like sine and cosine? Yes, it is, but looks very different. Now, what was the period when we had sine and cosine? The period of that whole wave was 2 pi. What's the period of this going to be? How long does it take for you to repeat one full cycle? From negative pi over 2 to positive pi over 2. So that's going to be another thing that's different with this graph. But that's what she looks like. We have a vertical asymptote. Maybe if we were graphing this on a diploma exam, we would say vertical asymptote. And I suppose on your diploma exam, we wouldn't abbreviate anything at x equals pi halves. And x equals 3 pi halves. We're going to have our next vertical asymptote. So for domain, we have to take out these vertical asymptotes. Our domain's going to be everything except for these vertical asymptotes. So how we write this is we're going to say that your domain is the set of x such that x can't be pi over 2. It can't be this vertical asymptote here. What else can't it be? Well, it can't be the next one or the next one or the previous one or the one back from there. So it can't be any of those. So we're going to start with that one is pi over 2 plus any of the others. And how do we get to any of the others? What are we adding to get from pi over 2 to get to 3 pi over 2? We're adding pi. How many times? N times. So we say x is not able to equal pi over 2 plus n pi, where n is an integer and where x is real. Woo! There's a lot going on with that idea. There's a ton that's going on with that. Let's just look at that one more time. So we're saying that x can't be, so that infers that x can be anything other than pi over 2 plus any plus or minus any multiples of pi added onto that. So that will give you all of your asymptotes, and we're just saying that x can't be those things. N is an integer because we're just looking at plus and minus whole multiples of pi. X is an element of the reals, always, always when we're looking at a continuous function, and that would be the case. Range, nice, it's much easier. All real numbers. So for sine and cos, our range was from -1 to 1, but for tangent, our range is all real numbers. To write this domain in interval notation doesn't really work because you have this repeated interval, and you would have to write it as lots of pieces, infinitely many. We're not going to write it like that. Let's just keep it in this notation here, in set notation. Period. How long does it take to do one cycle? Tangent is 1 pi periodic. Remember, sine and cos, those were 2 pi periodic. So tangent is 1 pi periodic. That means instead of having b is equal to, instead of having b is equal to 2 pi over period, which is what we had for sine and cos, instead of that, for tangent, b is equal to 1 pi over period. When is tan x undefined? And explain why. Well, tan x is undefined where we have these asymptotes. Undefined, and we kind of just wrote this in the domain, undefined when x equals pi halves plus n pi. Why? Because at tan pi halves, tan of pi over 2 is equal to y over x, which is equal to 1 over 0, is undefined. How far apart are the asymptotes? They are pi apart, which is the period. The general equation for asymptotes, that first asymptote would just be x is equal to pi over 2. The general equation means we want an equation for all of them. So very similar to what we did in domain. Pi over 2 plus n pi just means we're going to be adding whole number multiples of pi, or subtracting whole number multiples of pi, which works when n is an integer. All right, so a couple of examples through here. Use our graph of tan x to determine each value. Tan of 2 pi, just by looking at our graph. Tangent 2 pi is equal to 0. Tangent of 3 pi over 2 is undefined. Tangent of pi over 4. So the pi quarters in tangent are always going to be plus or minus 1. Tangent of pi over 4 is positive 1. And tangent of negative pi over 4 is negative 1. Determine the value of tangent of negative 3 pi. Well, tangent of negative 3 pi, just by looking at our graph. If we have negative 3 pi, well, at 0, it's 0. Tangent of 0, 0. Tangent of pi is 0. Tangent of negative 2 pi is 0. Tangent of negative 3 pi is 0. Because this is 1 pi periodic, then tangent of negative 3 pi will be the same thing as tangent of negative 100 pi, and those will all equal to tangent of 0, and all of those are equal just to 0. Write a general expression. So when is this at a height of 0? So theta is equal to 0 plus n pi. It's plus n pi because it's 1 pi periodic. That gives us all of the solutions is pi times n. When is it equal to when is tan theta equal to 1? On our graph that's asking for, when does this happen? When is that at a height of 1? And it's at a height of 1 at all of those places. When does that happen? Well, pi quarters, right? Pi quarters, theta is equal to pi quarters plus n pi, n being an integer. What is the period of 3 tan 4x? B is equal to 4. If we're looking at the period, do we care about a vertical stretch of factor 3? No. Vertical stretch of a factor 3 isn't going to affect our period at all. But we do have a horizontal stretch. What's our horizontal stretch factor? Horizontal stretch is of a factor of 1/4, right? As I mentioned, period is equal to, it's no longer equal to 2 pi over b. It's now equal to 1 pi over b for tangent. And if that's the case, it's pi over 4, which makes sense if it's undergone a horizontal stretch factor quarter. Number 5. If the graph of y equals tan x has a period of 7 pi thirds, determine your value of b. So just like period is equal to 1 pi over b, b is equal to 1 pi over period. Is equal to pi divided by 7 pi thirds. We are dividing by a fraction. It's the same as multiplying by reciprocal. So b is equal to 3/7. And our last one here. Since we know what a tangent graph looks like, we can draw a cotangent using our unit circle. Recall that cotangent is cosine over sine. It's better to always think of cotangent as this so we get the correct non-permissible values. If cotangent is cosine over sine, cotangent of 0, cotangent of 0, this is the point 1 comma 0 here. Oops. 0 comma 1 comma 0. I don't know what that is. Okay, so if there's the point 1 comma 0, here's your x, here's your y. And if cotangent is cosine over sine, then it's x over y. So at 0 degrees, this has a vertical asymptote. At 90 degrees, which is pi over 2, what do we have? We have 0 comma 1 is our coordinates there. And if it's x over y, that's 0 over 1. So at pi halves, cotangent of pi halves is 0. Our ratio of x over y, our x is getting smaller, but our y is getting bigger. So it should be decreasing there. At pi, what's happening at pi? 0 comma negative 1. And so we end up with, sorry, I messed that again. Negative 1 comma 0. Holy junk, here we go. So negative 1 comma 0, our x is negative 1 and our y is 0. So it's undefined. At pi, it's undefined. We could look at points in between. We could look at pi quarters. And at pi quarters, we have root 2 halves. Root 2 halves for our coordinates there. And so cotangent will equal 1. At 3 pi quarters over here, we have negative root 2 halves, comma, positive root 2 halves. And if that's the case, so it's x divided by y, so it's negative root 2 halves divided by positive root 2 halves is negative 1. And what this graph will look like is it'll look pretty similar to tangent, but kind of flipped around. It'll be always decreasing, and we have shifted where our vertical asymptotes are. So cotangent theta looks like this. All right, so that's pretty much it. If we were wanting to label these, I suppose we could say our asymptotes are at theta equals n times pi. Here n is an integer, and that would label all of those. All right, well, that's it for now. Good luck with this. Thank you.